Hello and welcome back to the channel. In this video we're going to solve this problem right here using the integration by trigonometric substitution method, and I'm going to break down trigonometric substitution from the scratch for you to understand and solve any problem you come across on trigonometric substitution. So let's get started. We're starting with this question to integrate dx over the square root of 4 minus x squared. Now, in trigonometric substitution, there are 3 points you need to note. Once you know these 3 points, integration by trig substitution becomes very simple, very simple. Okay, now the first point is that whenever you have a squared minus x squared, what you're going to substitute is x equals a sine theta. Point number 2, when you have a squared plus x squared, what you're going to substitute is x equals e tan theta. Point number 3, when you have x squared minus a squared, what you're going to substitute is x equals a sec theta. Alright, so when I come to this question right here, what I have is 4 minus x squared. So I'm going to come to my 3 points. What does this agree with among the 3 points? It agrees with this first point, which is a squared minus x squared, because 4 can be written as 2 squared minus x squared. So it agrees with the first point. So that means for this question, I'm going to be substituting x as a sine theta. So whenever I see x, I'm going to replace it with a sine theta. So I can come here and write this as 1 over the square root of 4 minus x squared dx. Okay, that's the same question here. And then I'm going to replace my x, 4 minus a sine theta. So a sine theta squared, right? The square root is still there, then dx. Now you take note of something. I have theta, right? And I have x. So I don't want to have 2 variables. I want uniform variability. So I'm going to say that since x equals to a sine theta, when I differentiate x with respect to the variable, which is theta, dx is theta. When I differentiate a sine theta, I have a cos theta. So dx is equal to a cos theta d theta. Okay, so I'm going to replace dx with a cos theta d theta. So this becomes the integral of 1 over the square root of 4 minus a sine theta all squared, right? Square root, then I'm replacing dx with a cos theta d theta. Okay, now at this point we can simplify to have this to be the integral of 1 over the square root of 4 minus, now what is a? What is a? Okay, a from here, looking at the correlation with 4 minus x squared and a squared minus x squared. So if I write a squared minus x squared here, I can see that a equals to 2. Okay, so this is going to be 4 minus 2 sine theta, right, all squared, then 2 cos theta d theta. Alright, so this becomes the integral of 1 minus the square root of 4 minus, so this 2 sine theta squared becomes 4 sine squared theta, and this becomes 2 cos theta d theta. And then it becomes the integral of 1 minus, when I bring out 4, I'm going to have 4 into brackets 1 minus sine squared theta, right? Then 2 cos theta d theta. Now we have to remember from our laws of trigonometry that sine squared theta plus cos squared theta equals 1. Okay, so when I take sine squared theta to the other side, I have cos squared theta equals 1 minus sine squared theta. So I'm going to replace 1 minus sine squared theta with cos squared theta. So I have this to be equal to 1 over 4 cos squared theta, then 2 cos theta d theta. Okay, I still have my square root there, so don't forget your square root. Square roots. Okay, so this becomes equal to 1. So when you take the square root of 4, you have 2, right? So this becomes the integral of 1 over 2, then square root of cos square theta is cos theta, right? So it becomes 2 cos theta, and then we also have 2 cos theta d theta. Okay, can you see how simple it becomes? So this cancels out and you're left with the integral of 1 d theta. And what is the integral of 1? The integral of 1 is the variable theta plus c. Alright, now I have to recall, right, that I substituted x as a sine theta. Okay, so that is x equals to 2 sine theta, right? Now we're going to make theta the subject of the formula because we want our final answer to be in terms of x, because you are integrating with respect to x. Alright, so what we have here, we're going to divide both sides by 2 to have sine theta equals x over 2, right? And then theta equals to arc sine, right? Arc sine, I'm write down very well. Arc sine x over 2. Okay, which means that our final answer is arc sine x over 2 plus c. Very, very simple. That's it. Very straightforward. In the next video, we're going to solve a problem where we have to apply a squared plus x squared and substitute this guy. See you in the next video.